Hello, this is Jack Jackson. I want to introduce you to something here that GeoGebra has kind of built in as one of their basic resources, and is a very powerful little probability and statistics calculator. And I'm going to show you a couple ways to get to it. One way is to just go to GeoGebra's basic site, which the home page looks like this, and just click on GeoGebra Classic, and then click on probability right here, and that will bring it up. Okay, so that's one way you can get to it. You can also get to it by looking at my probability and statistics uh, GeoGebra book. I actually have a link to it under discrete probability. It's also under continuous probability and inferential statistics because it's used for all those. But a little further down under discrete probability, you'll find it there. So you can click on that, and then you can click on this and say open it in the app will be the way I would do it. So either way you get to this, and it's you can do several things with this. So one thing you can do is for several basic kinds of distributions, you can see a graph of the PDF uh, bar graph there and the table over here. For example, let's look at a few different ones. These are some continuous distributions that we'll look at in a later unit. In Unit 3, we'll look at least some of these. And here's some of the ones that we're going to look at this semester in Unit 2B. We looked at binomial, Poisson, and hypergeometric. So let's look at binomial, for example. And you can see the PDF is just like vertical lines, or as we normally think of it in terms of bars. We can think of it, or we can see it graphed that way. So there's several different ways. The way we standard uh, way we look at it is with this. Okay. Then down here again, you pick the type of distribution. This is the cumulative distribution function. I would normally draw it without these vertical pieces, but otherwise it's the same way that I would draw the CDF. If you click that off again, you get back to the PDF. Let's see if the CDF has the table over here. Now to specify the particular binomial, you have to tell it n and p. So right now we have n is 20, p is 0.5. So the k or x values go from 0 to 20, but it's only whole numbers. And then you can see the probabilities that x is less than or equal to k. These aren't actually 0, but they round off to 0. And again, these aren't actually 1. Well, the last one's 1. And these round off to 1. So anyway, we can do that. We can also go back to this and see the values of the CDF table here on the right. Now you can also have it figure out different kinds of probabilities. For example, if I want to find the probability that x is between say 6 and I'll say 6 and 10, it will shade those particular bars in the graph and shade that portion of the table over here, and it will tell you what that probability is when you basically add up all those probabilities there, which are the heights of these bars, and it'll tell you that probability right there. So that's sort of a middle probability. You can do a left tail probability instead, I think. Yeah, there we go. So you have to click out of the box. Click that, and it's the probability that x is less than or equal to something. Let's say 11. And now it goes all the bars from all the way to the left, which in this case goes down to 0, up to 11. So this will be a value of the CDF there. But it can also do a right-tailed probability. So this is from 11 up to, well, the total, in this case 20. And it's adding those together. It can also do a two-tailed probability. So less than 6 or greater than 14, let's say. And so it's adding up these bars heights and the heights of these bars over here. In other words, adding up the second column of the shaded portion over here in the table. So you can do that. Well, that's for binomial. Well, you can also do it for some other ones here as well, right? You can do hypergeometric, for example. Here you do, this is what I've been calling capital N, the population size. Let's say it's 80. And N is the sample size. Let's say it's 15. And the sample means this is the number of successes in the population. I'm not sure why it says sample there. I wish it was, it's the number of successes in the population. So maybe there's 30. Okay. And again, you can do this same thing. You can see the table here. That's for the PDF. We can see the CDF there. We can see the like an in-between probability, like between 3 and 9, say. And we can see that shaded, these figured out and added up to be that. So it's a pretty cool little calculator. We also talked about the Poisson distribution. There's mu or lambda, which is the mean. So you give it that. So let's say it's 7. Okay, and it will work this out. This one does go on forever on the table. So there will be at some point where it gets down to, rounds off to 0, it will stop. Or it may just go out so many, I don't know how far down it goes, but it will tell you the mean and the standard deviation there. And up there, and we have probabilities picked out here. Again, you can do a two-tailed, right-tailed, left-tailed, or the middle kind of population, middle probability. So, for example, find the probability between 4 and, let's say 8, for example, and it will add those up for you. So it gives you a nice visual in the table, in the graph, of the probability you're adding up. And not only does it do it for those types of distributions, those three, there's another one called Pascal, which we're not going to talk about in my class, and those are discrete. And then it gets up here talking about some continuous distributions, and we'll get to those a little bit later in the course. Okay, so that's a nice little probability calculator that will illustrate what's going on. So it's a pretty powerful piece of software that they put together for us that works very, very easily and intuitively. There also, while we're at it, when you get to statistics, this does some inferential statistics, some of these things we'll be talking about in Unit 4. So we'll come back and use the same application here, or applet, for that as well. So yeah, this not only works for what we're doing right now, it'll work for more things later on. Good tool to use.